always. Any questions at all before we finish up doing quadratic functions that Hope started last time, and then get into a little bit of new stuff before we want to package? Sure. All right. So this, I believe, was the last problem you were working on right before Hope gave you some problems to practice on at the end of class. You've got a number of bacteria at a particular temperature. And it's asking you at what temperature would the number be minimal, and then what is the minimum number. By the way, remember where does a maximum or a minimum have to occur for a quadratic function? The vertex, right? You have the vertex. How can you tell if it's going to be a maximum or a minimum? What number tells you that's going to be a maximum or minimum? A. A. Good. If A is positive, it'll be a. It'll be a minimum because it's going upward, right? So the vertex will be a minimum. If A is negative, then it's a maximum. So in this case, they tell you you're looking for a minimum, right? Because it says when will, or at what temperature is it minimum? Is it minimal? And I can see that the A value, the coefficient on the t squared, is positive. Okay, so that's this number right here. As I throw my pen across the room, this number right here is telling us that we really do have a minimum that we're looking for rather than a maximum. Okay. All right, so how do we go about finding that minimum number? You had a couple of ways to do that last time. One way was completing the square, right? I do expect you to know how to complete the square, but when you're doing an application problem, we can use the shortcut. What was the shortcut? It's written on the screen.
Oh, the negative b over.
The negative b over 2a, right? Yeah, it's right here, isn't it? Okay, that's the shortcut. This gives you the, if you have an x and a y, that gives you the x coordinate of the vertex, right? Okay. So in this case, if we want to do the b over 2a, the negative b over 2a, what's the b value? Negative 20, because it's the one that's on the just the first degree term, right? The t to the first power. So we got negative of negative 20 on top. What's the a? 20. Yeah, I forgot my 2 times. Yep. And that should simplify to a half because the 20s will cancel and the negatives will cancel. In this case, this is a temperature and it's telling you that it's in Celsius. So this is a half a degree Celsius. So slightly above freezing. Okay, this is the shortcut way to get at the x coordinate of the vertex. Again, I want you to know how to do completing a square. It is a skill that pops up in the other classes. And it'll pop up again later in the semester, but in other classes as well. So I do want you to know how to complete the square. But if it's an application problem, you can use the shortcut to figure out the vertex. Okay. All right. So this is the minimum temperature. What do I do with that number now to figure out the minimum number of bacteria?
You plug that back into our overall.
Good. You plug it back into the function. Good. So the number of bacteria will be n of a half. So you get 20 times 1/2 squared minus 20 times a half plus 120. And if you put that in your calculator, what do we get?
115.
Say again?
115.
115? Okay. That's okay? Questions on that one? So again, if it's asking you when the minimum or maximum occurs, or at what value that it occurs, we're looking for the x. If you're looking for the actual minimum or maximum value, you plug it into the function and get that one back out. All right. So let's look at the next problem. This next problem has a slight little twist in it, in the fact that it's asking for something else that doesn't have to do with max or min. But it gives you the height of an object above the ground at a certain time. It wants to know when the object hits the ground, what time the object hits the ground, and then find the maximum height of the object. So the first part of that last sentence really isn't asking you about max or min. It's asking you about some other concept that has to do with functions that we're going to expand a little bit more on today. It says when does the object hit the ground? So the idea here is how high above the ground is the object when the object hits the ground? Not a trick question. How high above the ground are you if you're on the ground? Zero. Yeah, it's all on the ground, right? So what this is asking you for is basically asking when is h equal to 0? That's what it's asking you to do. So it's asking you when the output is equal to 0. Usually when we think about graphs, we think about the input being the x and the output being the y. So if we think about this as when figuring out when y is equal to 0, what things is it asking you about for the function? If you think about it graphically, if you're looking for when the output or the y is equal to 0, what things on the graph would you be looking for? If the y is 0, what do you cross graphically? The x-axis, so you're looking for the x-intercepts, right? So this is just so fancy, on an application purposes, this is just a fancy way to ask you for x-intercepts, right? It's asking when the output or the y value is 0. This is just asking a fancy way for x-intercepts. So in this case, we'll set our function equal to 0. And we're going to do more with x-intercepts today here in a little bit. Set your function equal to 0. Pardon me, goodness. So either we want to try to factor it or use the quadratic formula. Either one will work. If you don't see how to factor it right away, you can always use the quadratic formula, right? So what is your quadratic formula? It's a good review because we'll need to use it later this semester as well. What is the quadratic formula? Close. There's a 4ac in it. There's something before that. There's a b in it. B squared, and then there, it's all over 2a. Yeah, that's something you need to know. If you don't know it, I'd go back and memorize it again. Quadratic formula is one of those things that if someone stops you on the street 10 years from now and asks you what the quadratic formula is, you should be able to recite it. That's how well you should know it. Okay? That's one of those things that will come up. I'm going to expect you to know that you know it. Expect you to know that you know it? Expect that you know it. Whatever words I'm trying to say. All right. So in this case, what's b? 64. The 64. So you get negative 64 plus or minus square root of 64 squared minus 4 times, what's a? Negative 16 times 190. 190, and then it'll be all over 2 times negative 16. Good. Okay. So notice that there are 2 solutions. We'll always get, well, not always. Well, we might get exactly one solution if this turns out to be 0. But notice that we get a plus and a minus, which kind of makes sense if you think about graphically. If you've got a quadratic, a parabola that crosses the x-axis, if it goes below it, it has to go back up it again, right? If it goes above it, it has to go back below it again. We're going to hit it twice, right? That's what the plus or minus is telling us, so we're getting 2 of them. It's possible that you could get a negative under the square root. It just indicates that the graph didn't cross the x-axis, but there still are solutions to the equation. They'll be complex, and we'll do more of that later in the semester as well. Got all sorts of things I'm looking forward to. Or dreading, whichever way you want to look at it. All right. Did I give anybody enough time to type those in the calculator? I mean, it's okay if it comes out to be decimals. You should get two numbers.
Yeah, 129.5 and 125.5.
9.5?
Yep.
Okay. Seems a little big.
I don't know, I got a weird decimal when I simplified.
Yeah, there should be a weird decimal in there. I agree. Anybody get anything different?
I got 1.98 and negative 5.98.
1.98 and negative 5.98? I think I got the signs flipped around on that. I think I got negative 1.98 and positive 5.98. I think I got them the other way around. Did you remember your negative sign in the denominator? Maybe? Yep.
Negative 1.98.
Yeah. One of them is negative 1.98 and the other one's 5.98. In particular here, do they both make sense? Do both numbers make sense? This is a height of an object t seconds after something. Do both numbers make sense? In the context of the problem?
How did you get to those numbers though?
So you should have negative 64 plus or minus, let's see, if I can get the number, it was square root of 16,000 something. Okay.
Yeah, I got negative.
Yep, over negative 32.
Right.
Did you put parentheses around your top when you typed it in your calculator? So that one should be about negative 1.98 when you type it in. Because that square root should have been about 127 point something. Roughly. Did you get it?
Yeah.
Okay, cool. All right. Do they both make sense? Again, going back to the context of the problem. What would a negative t value mean here?
It's underground? Yeah.
Okay, well, t is time. Yeah, so if it was a negative height, it would be underground. If it's a negative time, it means what?
It hit the ground that many seconds ago.
Yeah, that many seconds ago, right? That would mean that it went back. The object went back in time, right? Did the object? You didn't throw it at the speed of light, so it didn't go back in time. So this one doesn't make any sense. It's this one that we're interested in. Okay. All right. That's finding x-intercepts. Like I said, we're going to we're going to do this concept more here in a minute, as well as on Monday. It's one of the reasons why I wanted to do that. But let's do the other part where we're doing maximum height of the object. That's the stuff that was in this particular section. It's asking you to find the maximum height. So is it asking you to find an input or an output? Is it asking you for when the maximum occurs or what the maximum value is? Yeah, it's asking for what the maximum value is, right? Okay. Pardon me. So how do we find that? What do we do?
Take our t and then plug it in.
So find your t. So how do we find the t to find the maximum value? What do we do?
Nope, we already have t.
That's where it crosses the ground. That's when it hits the ground.
Then when we took our t to equal negative b over 2 times
Yeah, we're going to do the negative b over 2a again. What's b?
64.
Okay, and a is
16.
16, negative 16. What value do we get? Get 2, don't we? We get 64 over 32. So we get 2. This is the time. Time is measured in seconds in this case. Good. Okay. But that's not what the problem's asking for. The problem's asking for the maximum height, right? How do we find the maximum height? Plug it in. So we'll get negative 16 times 2 squared plus 64 times 2 plus 190. 250, I'm sorry?
254.
4. And the units will be feet. Good. Yep. Good. Questions on that one? Again, the new thing that we talked about was finding where the maximum occurs and what the maximum value is. That's the new thing, right? We're going to do more with x-intercepts later. A lot of stuff with x-intercepts later. All right, I want to do one more. I'm going to skip the next one. I want to do the last one. So they've got 2 rectangular corrals. They're going to be side by side here. And we're going to create it out of 100 yards of fencing. Good thing they had a picture here because we wouldn't have necessarily known how they wanted to get the 2 rectangular corrals. But here they're going to be side by side. We want to maximize the total area and want to figure out what the dimensions need to be. All right, so this is pretty indicative of the type of problem that pops up. Well, this will be a good example of something that pops up when you're trying to do these maximizing or minimizing problems. Right now, I need to know dimensions. I need to know 2 things, right? Okay. So I'm going to put 2 variables on here just to help me out. Say that distance is x, and just to keep things a little bit simpler, let's say this dimension is y. And so that I can have a y and a y side by side, rather than trying to divide it in half later. Okay. What is it that we're trying to maximize, does it say? To find the maximum of? The total area. How do we find area of a rectangle again?
Area equals length times width.
That'd be volume. So it's just length times width. Good. So if I want the total area here, and I do length times width, what would I multiply together?
Y equals x.
Yeah, the x times the 2y, right? Because there's 2 of them on this side. All right, so I'd have 2xy. Right? I've got an x for the height there, the rectangle, and a 2y for the width, because they got a y and a y side by side.
So I'm trying to find, is the 2x coming from here?
I did x times 2y, and I just pulled the 2 in front.
Okay.
Yeah. Yeah, it's just coming from, I'll write it off. It's a good question, but that's exactly what I did. I wrote it as x times 2y, and then I just pulled the 2 in front that way. Yep. Okay. All right. Does this look like what we just found for maxes before, maximum or minimum before? Does this look like the type of function we did? No. In particular, there's too many variables. right? There's two variables, okay? Unless you're going on to third semester calculus, you don't deal with trying to find maxes and mins of functions of two variables. That pops up in third semester calculus, so that's like 4 semesters away, okay? All right, yes.
Don't we know how much space we have?
Not how much space we have, we know how much fencing, right? Okay, so that's what's going to help us get rid of one of the variables in terms of the other. That's exactly right. We need to use some other information. That was where I was going with that. I need to figure out something else in the problem that tells me how to get rid of one of the variables. We don't know how to deal with functions of two variables. We know how to deal with functions of one variable. All right, so there has to be something else in the problem that tells us how to get one of the variables in terms of the other. In this case, we have 100 yards of fencing. All right, how much fencing would you use to make those rectangles? 100 yards in terms of x and y. Sorry.
4 y's and 2 x's.
4 y's and you got the 4 y's, right? There's 1, 2, 3, 4. How many x's? 3, right? There's the middle one.
Oh,
There's a middle piece, right? So we've got 4 y's and 3 x's all together have to equal what? 100. Yeah, because that's the 100 meters of fencing, right? So now we can solve this for y. Oops. Subtract your 3x to the other side and divide everything by 4. Okay. So now we can plug this expression that we just found in up here for the y. So now we have our area in terms of just x is 2x times 25 minus 3/4 x. Pardon me. So that if we distribute the 2x through, you get 50x minus 3/2 x squared. Now, does this look like a function that we figured out how to find the maximum or minimum of? Yeah, this looks like exactly what we were doing with previous problems, doesn't it? Okay. What's the a value? The negative 3/2. Remember, even though I've got it written kind of backwards here, right? The a is the coefficient on the x squared. What's the b? The 50. Okay. So how do we find the x coordinate for your vertex? Yeah, the negative b over 2a again, right? You just told me the b was 50 and the a was negative 3/2. We get, what, 50 over 3 it looks like? We're done. Pardon me, goodness. So that's the x. Notice the problem asks you for the dimensions, right? How do we figure out the y?
Plug that in for x.
Yeah, we're going to plug that in for x up here, right? We have an expression for y, don't we? So the y will equal 25 minus 3/4 times 50 over 3. And then you get 12.5, so 25/2. I did my arithmetic right in my head. Lovely fractions. So the dimensions are what?
For each rectangle, it'd be 50 over 3 by 25 over 2.
Good. For each rectangle, it'll be 50 over 3 by 25 over 2. So for the whole rectangle, it'll be by 25. And what is it, yards? Is that what we had was yards of fencing? Okay. Again, notice what the process was in this one. My goodness. The process is we found what we were trying to maximize or minimize. We got that function. We said, hey, that's too many variables, right? So there had to be something else in the problem to get rid of one of the variables in terms of the other.
Is this going to be on the quiz?
Is this going to be on the quiz? Yeah. No, the quiz is just over inverse stuff. We're going to do a little bit more new stuff on the quiz. We're going to tweak mine. From, you mean up here? Down here? Oh, it was 25 over 2, and there's 2 of them. It was all the way across. It was the dimension of the big rectangle. So this one's 25 over 2. And that's 25 over 2. Yeah, so that'd be 25. We're going to do just a couple of definitions on this so we can get started. So we're going to finish it up on Monday. So we'll do the quiz. The quiz is short. So we'll do that here in a minute.
What do you mean degree?
So I just want to remind about a couple of definitions for polynomials. You should be familiar with polynomials. We'll want to do a couple of definitions today. And then we'll get started in earnest on the new stuff on Monday. So I just want to do the first page here real quick. Make sure we all remember our polynomial definitions. All right? Okay. All right. So scroll back into my front page here. All right. Do we remember what it means to be a polynomial?
In the written form of the function?
Yeah, it is, yep. So for the function, what has to be true?
To have a degree of 2.
Yeah, it has to have terms in it, right? So what do we mean by a term? What appears in your terms? So if you have an x, right? What could go out in front of the x? So yeah, some coefficients, right? Some numbers, right? What about the exponent on the x? What kind of number did it have to be? Could it be negative? No. Could it be a fraction? No, it had to be positive integers, right? So if f of x, so the way we get a polynomial is if f of x can be written in the form we usually write it as a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus a1x plus a0. Okay. Where the numbers, the a1, the a0, the a1 up to the an are real numbers. And the n is a non-negative integer. All right, that's a lot of math speak. Okay, it's a lot of math speak, right? So let's think about what it means. I just said it a minute ago. Do I see any negative exponents? No. So x cannot be in a denominator. Do I see any fractional exponents? A 1/2 or a 1/3 or anything? No. It says it has to be an integer, right? So I don't see any square roots. I don't see any cube roots. X is not under a radical. Okay? X is not inside of anything. Okay? It's x to a integer power. And it has to be a positive integer power unless it's 0 and you see just a constant all by itself. Okay? That's the idea. So I'm going to write down the definitions here in a minute, but this is a prototypical example of a polynomial. Do you see any x's in the denominator? No. Do you see any x's under a radical sign? No. Okay? Can't divide by x's, can't take roots of x's, can't put x's inside of other types of functions. Okay? When you see an x, it has to be to a positive integer power. That's what makes it a polynomial. Okay? All right. So what's some important vocabulary? Do you remember what the degree is? Yeah, the highest exponent on the x you see, right? So it's the highest exponent you see, right? So in this case, it would be the n, the way I have it written. Right, so in this case, for this polynomial, that's the n, right? What are the coefficients?
The numbers in front of it.
Good. Yeah, if the numbers you multiply by the x's, good. The numbers multiplied by the x's. Okay. So again, in the general polynomial I wrote, that's the a0, the a1, all the way up to the an. Okay. What's the constant?
Number without an
Yeah, the number without an x. Exactly right. Good. It's a number without the x. So if you look at the general thing that I have written up there, which number doesn't have an x next to it? The a0, right? That one, a sub 0, right? Okay. Do you remember what the leading coefficient is? So it's a coefficient, so it has to be one of the numbers. What do you think the leading part means? Yeah, it's the one with the highest exponent. Good. So the leading coefficient is the coefficient of the highest degree term. So in general, that's the a sub n. And then our leading term then is just that highest degree term, which in this case is the a sub n x to the n. So let's see if we can answer this for this specific example, and then we'll take your quiz. What's the degree? 4, right? That's the highest degree. The highest degree term we have there. The highest exponent we see is the 4. Can you list off the coefficients for me? So the coefficient itself is just the negative 4. Yeah, that's right. Okay. Yep. Good. Oh, technically the constant is also a coefficient, so yeah, it's 6. Yep, sorry. Those are your coefficients. How about your constant? What is the constant term? The 6 on the end? Your leading coefficient? Good. And your leading term? Yeah, it's the whole thing, right? The negative 4x to the 4th. Yeah, good. The reason why we want to make sure we can identify these is because the constant tells us something about the graph, and the leading coefficient and leading term tells us something about the graph. Okay? That's why we want to make sure we can identify those. That's why I want to make sure we got that talked about today, just really briefly. You should have already talked about this before in another class, but let's make sure we're all on the same page. Because it'll be important to us to be able to use that information to get graphs. All right. Short quiz is just for one side. There's no, not two-sided today. This is a short little one. Just remember, just try to reinforce the inverse stuff. Make sure we're all on the same page with that too.